This lesson is for 6th grade, lesson 1.4 GCF, or greatest common factor. So today we're going to be talking about greatest common factor GCF. So I'll remind you that a factor is the numbers that we multiply together to create another number. So for example, the factors of the number 16 would be like 1 times 16. Also, you could do 2 times 8, composite number, right? He's got friends. Also, you could do 4 times 4. So all of my factors for 16 are 1, 2, 4, 8, and 16. And so if I were to be looking for the greatest common or shared factor, I'd be looking for the largest of all the list of factors between two numbers that they share. So this lesson is going to give us practice to do that. This GCF, or greatest common factor tool, is it will come in handy. It comes in helpful for many future math skills that you'll be using, and you won't think of it as GCF. You'll just know that it's a tool that you find it with. But it will help you simplify fractions. It will help you with the distributive property, which becomes very big next year, and then very, very big the year after. So we want to be really comfortable with it. And also can help you with things like questions where something might meet up again, like something starts on Monday and something else starts on Tuesday, and one goes every 3 days and one goes every 5 days. At what point will they meet again? All right, and so similar to when we did lowest common multiple, LCM, GCF, greatest common factor, has a lot of different ways people will find it. And so you'll just choose one that works for you. So this lesson will show you a couple of different ways, and then you'll be like, I like that one better than that one, and you'll do that. You'll get into later math years, and you might come across a teacher who says, oh, I do it this way. This is way easier, and they'll show you, and it might seem like, yeah, that's way easier, or it may seem like, no, I'll keep my way. So there's a lot of different ways to find it. I'll show you a few in this lesson. I'll show you the ones the book does. I will say I have another way that I do it myself that I learned in college and was like, wow, that's way easier for me. But I'm not going to show that to you today in this lesson because I don't want to overwhelm you with a bunch of ways. Our brains work differently, and as long as you grasp one of these, then we're good. If not, then you can let me know, and we'll talk about other tools I've heard of that might help too. So the first way is just simply to list them, sort of like LCM, but this time we're not doing their multiples. This time we're doing where you count by the numbers. This time we're doing their factors, what numbers multiply together to get them. So if I was to find the GCF between 12 and 18, I'm first going to find all of the factors of 12 and all of the factors of 18. And I usually just kind of list them out. I try to keep them in an order. So I'll go 1 times 12. Then I can do 2, so 2 times 6. And then how about 3? Yeah, 3 times 4. That's going to be it, though, because once I go to 4, it's already there, and it's just going to work its way back up. That's why I try to keep it in an order here, because then it works its way back up over here. So all of my factors for 12 are 1, 2, 3, 4, 6, and 12. 1, 2, 3, 4, 6, and 12. Now I'm going to do the same thing for 18. I know that 1 times 18 makes 18. It's even, so I know that 2 times something does. That would be 2 times 9. 3 times, does 3 divide evenly? It does, yeah, actually, because 3 times 6 is 18. How about 4? 4, 8, 12, 16, no. 5, 6, no, now I'm back at 6 again. So that's it. These are the factors 1, 2, 3, 6, 9, 18. So I'll list them out under here. 1, 2, 3, 6, 9, 18. And now I'm just going to go ahead and look for matches. That's a shared factor. That's a common factor. That's a common factor. That's a common factor. And that's it. remember I'm looking for the greatest common factor or the largest common factor, and that would be 6. So the GCF of 12 and 18 is 6. So that's one way to find it. And I feel like that one is kind of my backup plan to the one I usually use. That one I'm pretty comfortable with, is just finding their factors and working them out. Actually, at some point, some of these numbers, you see the numbers after a lot of practice and you know, like 6 is the biggest number that goes into both of them. You kind of think of it that way. Another way is to use a Venn diagram, just like you did with LCM. And many of you might like this way because after the first few lessons of the chapter, you're probably a little more comfortable with using prime factors and the Venn diagram. So maybe this is the one that makes you feel like this is the one I like. So let's look at how this one's done. To do the Venn diagram way to find GCF, you would break down these numbers to their prime factors. So you would do those factorization trees, right? So here's 12 and here's 18. What numbers can, other than 1, what numbers can I multiply together? I can do 2 times 6. 2 is prime, so I'm done there. 6 is not prime, so he gets branches. Let's see, 2 times 3 makes 6. 2 is prime, and 3 is prime. So my prime numbers for 12 are 2, 2, 2, 2, and 3. Then for 18, let's see, I can do 2 times 9. 2 is prime. 3 times 3 makes 9. And those are prime. So there's my primes for both of those numbers. 12 has 2, 2, and 3. And 18 has 2, 3, and 3. And so then I'm going to do my Venn diagram where their shared ones go in the middle. So these are the prime, or the numbers, prime factors for 12, and these are the prime factors for 18. I see a shared 2 right here, so I'll put that in the middle, cross it off so it doesn't confuse me. This one has a 2 still left, but this one does not. So I'm going to put that in the 2's over here. Cross him off. We have a 3 here and a 3 here, so that's shared. Cross them off. And then this one has a 3 left that this one didn't have, so he will go over here. And then once you have done that and found out which are shared and which are not, the area that you're going to pay the closest attention to is this shared section right here. That is what's going to give us our GCF. So we're going to multiply together the shared section to get our GCF of 6. So that's another way that you can do that. Okay, and now we're going to get into talking a little bit about kind of your early introduction into the distributive property, which becomes really important as we get into 7th and especially 8th grade math. So it's kind of a foundational piece that we want to cover. And first, I want to show you that in your book, it will say 5 times with the times symbol that you're used to, 8 plus 6 in parentheses. You will start noticing that sometimes the multiplication symbol that you're used to is sometimes written this way, and your brain will start to get used to that. I just wanted to point that out to you so that the first time you see it, you're not like, what in the world is that? So this little dot means multiply, and I pretty much have switched over to that. I just switch back to this usually when I'm working with numbers that have decimals, because then this starts to look like a decimal and I get confused. So you'll see me go back and forth between these two symbols. Also, in this scenario, these parentheses, if this number is right next to the parenthesis and there's no sign telling you what operation you're doing, we all get used to the fact that that means multiply. So these all mean the same thing. This is 5 times the sum of whatever 8 plus 6 is. 5 times 8 plus 6. 5 times 8 plus 6. These all mean the same thing. So I wanted to point that out to you too. All right, so I'm going to show you about how to distribute in, because sometimes you need the number distributed in, and I'm going to show you how to reverse that and distribute out, because sometimes you need the number distributed out, and that's where knowing how to do GCF comes into play. So, and I know you're probably looking at this and saying, Ms. Sanchez, I don't I don't need to know how to manipulate this number around. I know order of operations, that I do this first and multiply by 5. I could just do that. Can't I just do that? And yeah, technically you can. Yes, absolutely you could. However, I wanted to use simple numbers, and I just wanted to use numbers and not letters, variables in there. But I'm going to tell you that at some point you're going to get to a point where the math involves a variable, and you're not going to be able to add those together. It'll say x plus 6, and x just means I don't know that number yet. So how do we get around that until we do know the number? How do we simplify things till we do know the number? We use the distributive property. I'm going to use numbers to show you that. So yes, I do realize you could just calculate that and get the answer. But my purpose for showing you this with numbers is to help you understand the property and how it works, so that as we go further into math, you know that that's a manipulation that you can do. So really what I can do is, rather than just say, oh, okay, 8 plus 6 is 14, and then I multiply by 5. I can use the distributive property. This is 5 times everything that's inside of these parentheses. So I can rewrite this as 5 times 8 and also add it together with what the other part that's in the parentheses, this 5 times 6. And then I could calculate that if I had the information and get the same answer. These two calculated will give me the same answer. So yeah, I know you just calculate it. But again, if I'm dealing with a variable that's messing with me in here later, and there will be variables messing with us later, this is a way to move around it. So you could do the 5 times 8 plus the 5 times 6, the 5 being multiplied times everything inside the parentheses. And I call that distribute in. Okay? Let's go ahead and calculate that so I can show you the reverse of that distribute out. So we know that 5 times 8 is 40. And we know that 5 times 6 is 30. And so we know the answer would be 70. Okay. But let's say we were still dealing with variables and all that. So let's look at the reverse of distribute in. So it's, again, we're not worried about the final answer in this. We're just worried about the fact that we need to be able to know how to distribute in and distribute out. So when we're looking at a problem like this, and if we had variables involved, we'd need help with this. We would distribute out. And all distributing out is finding out what common divisor or what common factor they have that goes into it. Normally, our goal is to find the greatest common factor. So that's where I would use the tool that you learned in those examples before. In this case, because my goal is to get you to recognize the in-ness and then the out-ness again, I'm going to use the same factor that we used before, where we did 5 times both of these. I'm going to divide them back out again. So I could divide by 5 from both of these if I needed it to look in this format instead of this format. It just depends on what math we're doing as we're in more advanced math. Sometimes I need things looking this way, so I need to know how to get them there. And sometimes I need things to look this way, so I need to know how to get them there. So if I need this to look like this, I distribute in. If I need this to look like this, I distribute out. So I just go ahead and pull a common factor out. I know that 5 divides evenly into both of those. So I would say, all right, I'm going to divide 5 away from that and divide 5 away from that and put 5 on the outside. How many 5s fit into 40 equally? 8 do. And how many 5s fit into 30 equally? 6 do. And there it is looking back like this. So again, it's not anything we really need to worry about when we've got all the numbers involved. It's something that comes into play later when we have to deal with the variables and getting around the fact that there are variables there. You will become very comfortable with it. This is just your first look at the fact that we can manipulate these to look this way or that way or this way again. So Just a heads up on that. If you're a little shady on that, that's okay. We'll see it more as the year progresses, and then you'll be comfortable with it by the time we hit next year. So now, bearing that in mind, let's see if this can help us answer that question, because we're going to use that distribute out thing. What they mean by the question that says show 36 plus 27 as a product, they mean show it like what we saw before on the previous slide, 5 times 8 plus 6, or whatever times those numbers that will go inside. So we're going to use the distribute out to figure that out. So first thing I want to do is to find the GCF, the greatest common factor, that goes into 36 and 27. So I can know which is the largest number I can pull out of both of them. I could divide out of both of them. Okay? So I'm going to use the listed way, because that's the way I'm most comfortable with. 36 factors and 27 factors. So for 36, I get 1 times 36, 2 times 18. 3 times 12. Does 4 go into 36 evenly? Oh, yes, it does. 4 times 9. 5? No. 6 times 6. And then now that they're balanced again, they just go back way up. So 36. I just realized in my notes for you guys that I left that off there, the 6 times 6. Oh, well. 1, 2, 3, 4, 6. We already used 6, so 9, 12, 18, and 36 are all of the factors of 36. Let's look at 27. I can do 1 times 27. 2 won't go into 27 because it's odd. 3 will. 3 times 9. 4 will not. 5 will not. 6, 12, 18, 24, no. 7, 14, no. 8, no, that's it. Looks like the only factors of 27 are 1, 3, 9, and 27. Okay, so now I want their commons. Common factors is 1, 3, and 9. 1, 3, and 9 are common. The largest common one is 9. Okay, so now taking that number and knowing their largest shared divisor is 9, their largest common factor is 9, I'm going to divide both of them by 9 and pull that out to be the multiplier. So it will be 9 times something. 36 divided by 9, well, remember 36 and 9 over here. So you had 36 and 9 over here is going to be 4. It's just the reverse, right? And 27 divided by 9, well, 27, the 9 over here was a 9 times 3, so that's going to be 3. And this is the answer they're after for that. If they say, write it as a product, they want you to find the GCF of these two numbers and then divide that GCF out of those two numbers and set it on the outside. That's all they're looking for if you see a question like that.